All right, good afternoon, everyone. Our next speaker is David Anderson. David is involved with valve conditioned and performance monitoring equipment and systems, including the Midas meter, ultra-portable handheld valve leak detection, quantification, and trending tool, the Midas sensor, permanently installed sensor for continuous valve leak detection, quantification, and trending, and the VMAP G3, a fully integrated critical valve condition and performance monitoring system, which trends valve and operator performance and reports indications of any and all developing failure modes. So with that, David, we're going to turn it over to you, and we'll mute on this end until questions. Thank you.
Thank you very much for the introduction. Good afternoon, everyone. I'd like to start by looking back at a report which was commissioned by the Oxfam organisation in the UK, and the findings of which were released by the CEO, Dhananyavan Sriskandarajah, if I have pronounced his name correctly. They have, like most organisations, this aspiration to reach net zero emissions by 2050. And the findings of the commission that they put together was that in order to reach net zero by 2050, just by offsetting through planting trees, the estimate was that we would need 1.6 billion hectares of new forests to be planted right now to achieve that by 2050. Now, let me put that in perspective for you. That is about 5 times the size of India, and it's more than 2 times the size of the entire landmass of the United States of America. So I think we can all agree that in terms of how we progress moving forwards towards that net zero aspirational target, planting trees is not the only answer that we need to be looking for. Yes, it's great that we can do that and it's part of a mix, but there really has to be some other higher level of solutions available to us, and that's what I'd like to talk to you about today. We don't just want to reduce emissions, we want to completely remove emissions from our process plants. And if we can do that, we can remove huge amounts of emissions in a really short space of time. And that net zero target starts to look a lot more achievable if we deploy the correct technologies at the correct time. So let's dive into some of the materials here. Our promise is that we want to help everyone in this game together achieve long-term sustainability. We can only do that if our environmental footprint is correct, if our profit margins are correct, if we look after our people and our processes. So this is, excuse me, not just about reducing emissions. There's a bigger aspirational goal here, and I'm going to touch on that subject a couple of times as we go through the presentation here. In terms of what we deliver for our customers, yes, this whole conference is about the environmental impacts and how we can have a better footprint moving forward. So we really must start with that environmental discussions. What is it that we're going to do that's different moving forward from what we've done in the past that's going to deliver that sustainability moving forward? A lot of the discussion in the marketplace right now is about compliance issues. It's about, regulations. It's about standards. There's a bigger and more aspirational goal for me, which I'm going to touch on as we run through some of these other areas. In terms of our people, process and plant, we need to make sure that we're operating safely and we're protecting the health of all our employees. Now, the health of our employees is only the start of the equation, because if you look, for example, to the Far East and some of the air quality issues they have in some of the major cities over there as a result of, for example, burning coal to produce energy, you start to see that the wider population is also at risk from these industrial activities as well. So health and safety is not just about what happens on the plant, it's what happens outside the plant as well. Of course, in terms of what we're doing in any operation, we're not going to be sustainable if we don't make profits. And it's really important that we focus on where the major impacts of emissions are taking us in terms of that invested capital delivering returns equation. So I'm pretty sure everyone in the room fully understands the difference between the cost of a valve repair, for example, versus the cost of downtime. One is a small number, one is a really big number. And the big number, of course, is associated with those unplanned outages that you're going to see when valves don't perform their intended functions. So we really need to have an eye on this. What is it that we can do in terms of that asset integrity management piece that allows us to make sure that we generate the profits that allow us to keep investing in our processes and our systems and our manufacturing, in our energy production, and all the things we need to make society function as it functions today. In terms of that production model, the way to bigger profits is to go for optimized production efficiencies. So again, we can talk about the uptime of the processes, we can talk about the minimization of downtime, and we can really look at how we get that quality program running and that asset integrity management piece running correctly that delivers those major advantages in terms of sustainability. Of course, the last thing which is highlighted here is reputation. The impacts of disasters, whether they be environmental disasters or accidents or incidents, then that has an impact not just on the operation itself, it has an impact on the whole community. And we don't need to look further than the impacts of Deepwater Horizon or Piper Alpha or the Exxon Valdez. You know, historically, we have lots of reference points here where organizations have run into reputational difficulties and had massive amounts of PR work to do to recover from these really quite catastrophic, unique events. So the more we can do at the front end to mitigate our exposure to those high risk moments in time, the better we're going to be in terms of sustainability. So as I said at the start of this slide, whilst we're here to talk about the environment, we should really be taking a holistic approach and looking at all of the impacts of everything that we do and how each of those component parts fits together like a jigsaw to make sure that we do the right thing at the right time to make ourselves sustainable over the long-term period. There is no major organization in the world who are in the energy industry who are not now committing to grand plans for whether it's net zero or reduced emissions based on X year to X percentage of emissions reductions. Everyone's doing it. We have a champion in the UK in the CEO of BP. You probably know Bernard Looney. You'll have seen him in the news. You'll have seen videos. He is really passionate about making sure that BP is correctly positioned for that long-term sustainable model. And he's put in place some pretty exciting targets about what is required in the marketplace to make some of these things happen. And it's not just focused on what they do in an operational sense, it's how their products are then used in the wider community, in the atmospheric scenario where we talk about everyone involved in the equation reaching that same low carbon footprint. So as I said, it's not just BP, we've got Shell, we've got Total, we've got ExxonMobil, we've got Chevron, we've got ConocoPhillips, we've got Repsol, we've got Petronas, we've got Saudi Aramco. Everyone around the world is now acutely aware that they have to be moving down this pathway of renewable energy and reducing carbon footprints. So in terms of how we might look at that from an operational perspective, let's have a look at where BP are investing their cash. $270 million going in to improve efficiency and reduce emissions. at the Cherry Point refinery, which is working on renewable diesel production. So some statistics in and around that, a 7% reduction in emissions based on that $270 million investment is going to take 160,000 tonnes of emissions out of the atmosphere, carbon dioxide specifically, as they move that process plant forward with that new investment. Doubling the production capacity effectively means they're halving their production costs. So again, when we look at that sustainable profit margin model, it's going to be there for them for a long time to come if they deliver on this project that they're investing in currently. And look at this last bullet point here, 300 new jobs being created over the next 3 years. So yes, we're focused on the environment, and yes, we're focused on emissions reduction, but there's a huge amount of spin-off benefits and lots of other things that are positive that are going to happen when we get this model correct and when we get everyone thinking like BP about where to invest sustainably in the operations to take them forward. In the USA, of course, there is a huge industry in and around compliance issues in terms of emissions permission levels and all these things that you're familiar with from the EPA, BSE, in terms of those consistent applied rules for verifying that mechanical assets are performing as they should be performing at specific time periods. That is well known. We see changes in appetite for this message, depending on which party's in the White House or which president happens to be leading us at any one point in time. But as I've said many times in the US market, it doesn't really matter who's in the White House. The general direction of travel is towards reduced emissions. So the sooner we get on this message and the sooner we start making these reductions happen, it's not really going to be of any significance who's in the White House at any one point in time. So we have to accelerate our investment towards that lower emissions economy. It's a win-win situation. When we look at this as a whole, we can start to see where the benefits are going to come for everybody who's involved in that jigsaw puzzle that I mentioned previously. In terms of energy transition, what are the new technologies that are coming into play? What's this messaging around renewable energy? Because if we can reduce the carbon footprint of energy production, that's already having an impact for us in terms of our scope 1 and scope 2 emissions from our operations. When we look at those compliance requirements, we can talk about operating companies being pushed into a situation where they have to comply. But I would rather have our whole industrial model looking at the advantages and flip that over into a pull scenario where the operating companies are really keen and really eager and really hungry to see what these solutions might be, what those new innovations might be that reduce their carbon footprint anyway, and get all those other spin-off benefits about improved efficiency, improved uptime, better profitability of the plant. If we can get that message loud and clear in the marketplace, then the compliance standards will be a secondary event because operating companies will be running towards the benefits instead of living in fear of those compliance requirements. They'll just happen anyway. There is an unintended consequence, which I'm going to come back to in that respect, but I'll come back to that in a later slide. In terms of access to capital for funding purposes for all these new projects, investment capital organizations such as the banks and private equity companies, they're all looking at this environmental and social governance issue and saying, is this a company that I can invest in? Is this a company that takes the environmental model seriously? Are they running towards technologies that are going to help them be sustainable moving forward? Because no one's going to give anyone capital if it's not a sustainable growth industry. Capital investors want money back and they want interest on that money back too. So if you're not sustainable, it's unlikely that they're going to get a return on that investment. So guess what? Without a proper environmental and social governance policy in place and a real passion for delivering on these policies, organisations are not going to get investment capital to invest in their organisations moving forward. So again, join all the dots back together, make sure we're doing the right thing at the right time, and the money will flow and the emissions will naturally be decreased over time. So in terms of the hierarchy of emissions reduction, we can talk about 4 key areas. We can either reduce our consumption of energy. So that's the, I guess you could say, indirect cost of running your operations. So that might be the power plants that are running to generate the electricity that turns the pumps and the motors that run your processes. We can talk about replacement technologies. So instead of burning fossil fuels to create that electric, can we generate that electric from renewable sources such as solar or wind, or some subsea turbines looking at tidal waves, or not tidal waves, tidal currents, or wave machines on the surface of the sea. Lots of opportunities for us to replace that energy mix over time. It's not going to happen overnight, of course, but we need to be aware of it. We can then start talk about removing emissions from our operational activities. So removing those might be some sort of repair program that's in place. We can start talking about even removing gases from the atmosphere and looking at carbon capture and storage, for example. Or when we drop down into the offsets, this is where we start getting into, can we offset one emission against another? Is that planting a tree? Is it planting some seagrass? There's lots of things to do in the mix. But what we really want to do is make the biggest possible impact in the shortest possible timescale. So we should be doing all of these things in tandem, in parallel. But of course, let's do the big things first that give us that immediate return on investment and the big advantage in the shortest possible timescale. In terms of compliance, what we're seeing around the whole world, it's not just in the USA, where the EPA have renewed in vigour in terms of the support they're getting from the White House currently. It's happening all over the world. Everyone is on the same message. We in Scotland had COP26 over in Glasgow, which I attended, and there was some great ideas, some great energy, some great innovations. But we really need to roll that out now. We can't just have that as a talking shop. We need to run towards investing in these future sustainable, deliverable sustainable options that give us these advantages in the fastest possible timescale. All of these white papers, all of these compliance standards around the world are all pointing in the same direction. What they're talking about is quantification of leaks so that we can take that top-down approach. Go after the big emitters first, and then we're in the laws of diminishing returns. Different countries around the world have different appetites for this. There's no escaping that. This is a conference that's happening in Austin, Texas, but you're not living in a bubble. The whole world is talking about this. And what we're looking at here is the International Energy Agency's summary of just some of the countries around the world who are getting involved in documenting what it is that they want their operating companies in their countries to do moving forward, whether it's a prescriptive standard at national level, a performance-based standard at local level, looking at some of the economic drivers, looking at what information gathering is required so that we can then use that to inform our decision-making processes. Again, what you're looking at here is the list of countries from page 14 of that document, and you can see the blue dots are where there is a national policy already in place, and the clear dots are where there are local policies in place. And you can see that in the United States, you're pretty much ticking every box in every column. with the exception maybe of one there or two. Canada leading the way with a whole load of prescriptive requirements at national level, and Mexico too, also forging ahead with their compliance requirements. What is going to happen moving forward is there will be more dots on this page, and there will be more countries on this page, and things will become a lot more prescriptive. So we're giving you a chance now to look at what arrangements you have in place, where you may have some gaps, and where you might want to take that forward to plug those gaps and get ahead of the demand curve. So we're not the only organisation helping companies reduce their carbon footprint, but what we are doing is we're trying to take this holistic approach, this asset integrity management space, which is becoming more and more digital. Nothing written down on a piece of paper with a pen, everything using the ability to gather data electronically and transfer data, using algorithms for rapid analysis of survey work, whether it's handheld tools reporting digitally or permanently installed systems reporting digitally, and collating all that information back together in an evidence database, where, as I say, it's going to start to generate some of these work orders that allow us to go and address the biggest emissions in the shortest possible timescale. So we have to take this connected approach. We talk about intelligent valve management. We're a valve company. We started doing valve repairs before we got into all these digital tools and emissions monitoring and producing our own internal equipment and systems and manufacturing new innovative equipment. So we understand where the problems are, and we know exactly how to fix those problems. So that's really the next step in what we're going to talk about. A 4-step approach to emissions elimination. The 4 steps are very simple. We need to go to source, and we need to use the correct tools to find the leaks. So that requires us to select the correct tools and actually go and do the survey work. Once we have the data from the survey, we then need to analyze that data and say, what is it that we need to do next? What is the data telling us? Where are the big gains likely to be made? We can then start our mitigation process. So this looks like the temporary repairs. It looks like those in situ repairs, the quick and easy fixes that give us those rapid gains in emissions reduction. Of course, we don't want to stop there. I said it's a 4-step process. The last bit of it, the closed loop element of what we're doing here, is to do a complete engineering review on recurring failure modes, for example. So if you start to see the same failure happening time after time after time, then clearly there is a design modification opportunity there, which allows us to engineer out that recurring failure mode. So all of what we do is driven by our knowledge of failure modes, our expertise, and our pre-designed repair programs that remove all these emissions, again, in the shortest possible timescale. So this is a continuous loop. It's driven by our knowledge, experience, competency, capability, and the availability of the correct tools being used by the properly trained personnel. Once we do that, we can rest assured that we're going to have the biggest possible reduction in emissions over time. So we always talk about taking a find it and fix it approach. There's me on a gas plant over in, that picture was taken in China, and that's me using our Midas meter device to look at valves across the whole plant and say, what is leaking, how big is the leak, and what we're going to do about it once we've found it. Of course, what we really want to do when we find it is make these things go away. So I've very consciously and very deliberately showed you a really horrible flare, which is about, well, let's just say it's about 5 miles from my house here in Scotland. And when this happens, generally people in the local community get upset. So in the UK, 25% of all emissions are coming from industrial processes, and about 75% of those emissions are coming from flaring and venting exercises. So if we can go after these using our equipment and systems, then we'll have already gone a long way to achieving that net zero figure in a really short space of time. So our start point, as I said before, let's go and find the leaks. Once we know where they are, we can move towards that model of zero leaks and emissions. It's a journey. We're not going to deliver all of this immediately, but we need to start running in that direction and take the necessary steps. We will start with the quick and easy fixes, the non-intrusive and temporary repairs, but we will end the process by doing those planned outages, by deploying the enhanced engineered solutions that makes these emissions go away, not just in the short term, but over the long term, the longest possible life cycle of the process plant. We know that in terms of what we're looking for, the greenhouse gases are the ones that we really want to go after. Principally, carbon dioxide by volume is probably the #1 target. But if we go for maximum damage to the environment, then the #1 target really has to be methane, which is more than 80 times damaging to our environment. Now, when we're going after these gas emissions, we have to understand that some of them are easy to find and easy to see. Others are a little bit more difficult. So we can look at the iceberg analogy here. Above the surface of the water, you can see everything that's going on, things that are happening underneath, which is perhaps maybe even the majority of emissions. They're not so obvious in terms of the sources. So when we start selecting the equipment, what are the things we're looking at? Is it leaks to atmosphere? Is it losses to flare? I've already said the percentages where the big gains can happen. Once we go subsurface, the things that are a little bit more hard to find, we start looking at vents and drains. We start thinking about those system inefficiencies. What is it that we're doing in terms of driving our process? If we've got, for example, losses on an airline, then our compressor's working a lot harder. It's consuming more electric, which means we're producing more CO2 to produce more electric to run that compressor harder. So you can see there's dominoes that are falling throughout this whole process as we operate on a normal basis on our operating plants. Things that are hidden by, for example, we might see corrosion underneath insulation. How do we find that? How do we mitigate against those leaks happening? We need the right tools and equipment to go and find them. So in terms of our process plant, we can start looking at the selection of equipment. Leaks to atmosphere, optical gas imaging. We can use those sniffer devices. Anything that's going to give us an advantage in terms of quantification also gives us an advantage in terms of prioritization of our repair work orders. Losses to flare. Again, our handheld tool, Midas Meter, looks at acoustic emissions through seat leakage. That's valves that are not holding back the process fluid gas and letting it go to flare, and it's then being burned off in the atmosphere. Lots of opportunities there. System inefficiencies, we've talked about that extra energy required to run the process, but it could be actually connected with the process itself. Maybe just the process isn't working correctly or to the maximum quality standard or efficiency level. So thermal imaging, ultrasonics, we've got Midas sensor permanently installed options in the VMAP, as you heard in the introduction, some of our own products, and other complementary condition monitoring tooling. You just have to walk around the exhibition here this week and you'll see literally hundreds of different tools that can be deployed at any one point in time. Pinpointing those against the failure modes is the key to success. When you join it all back together into a single program, that's when you make the maximum gains in the shortest time scale. The losses to vents and drains and the non-fugitive emissions, again, different types of technology to still go and make sure we're getting the earliest possible indication that these leaks are happening. Excuse me. So we've given a quick overview of where some of these tools could be used. Visual inspections, using those tablet devices to run through a checklist, that's a human intervention. You know, most plant managers will tell you there's nothing more valuable than walking through the plant and just using your eyes to have a look and see what's going on. So this visual inspection, 40 odd points, we can capture that information in a database that someone else might want to review and interrogate later on. Through seat leakage, those flares, vents and drains, importantly, quantifying it, not just understanding that it exists, but which are the valves that are causing the biggest problem. If we go and fix them first, then we'll make the maximum impact in the shortest possible timescale. We can also, once we start putting a time and date stamp next to every survey, look at how that leak rate is changing over time. Optical gas imaging, again, a really good way of surveying a wide area in a short space of time. Just by scanning across from a distance, you can look at multiple valves or multiple potential leak paths in a wide area basis. So again, it speeds up that process, which will then allow you to localize in using other tools to start getting involved in quantification, because what that won't do is it won't quantify the gas that's escaping through the leak path. Some really sensitive tools are available. When we start to talk about the gas analyzer devices, we can start from literally 0 ppm. And this is way beyond anything that you would get with optical gas imaging. When you start dropping to those ppms, and again, the EPA standards that we've spoken about, the compliance requirements, they all have very clear, specific numbers that must be adhered to in terms of compliance. And so you do need all of the tools. You can't just use one tool and expect to have all of the results that you need for those compliance purposes. Airborne ultrasound, again, useful for sweeping larger areas and then homing in on where the source of that leak is. Some of these tools will do quantification, and if you've got a choice between the ones that will and won't, I always recommend go for the ones that will help you quantify those leakage rates. Thermal imaging, lots of different uses for that, not just on process fluids, but you can also get the benefits of electromechanical failure modes as well. So it's not even just about emissions. What else can we use these tools for while we're doing these surveys to marry up against other efficiency gains that we can have in our systems? CO2, again, big target for these thermal imaging cameras, and steam losses in systems, really easy to spot when you use the right tools in the right place. Of course, what I've described to you is really just touching the surface and scratching the surface of all of the tools that are available. But what I find when I start having this conversation with customers is that they get confused about which tools to use at which point in time. So we've created this Ready Reckoner to help guide our customers through what is it that you're looking for, what are the sources, what type of technology will find the source of those emissions, and then which part of the program or that 4-step program do we need to deploy at this point in time to help you on that journey towards zero emissions. So a lot of guidance available from organisations like ourselves who have joined all the dots back together for you. Valves are, as I said, our core, our primary start point, because we started off as a valve repair company. This is a study that's very often rolled out, widely rolled out from the British Columbia University in Vancouver, which said that most of the problems, 75% or more, are coming from valves on the process plant. So if we fully understand the valves and where the leak paths are, then we can start to think carefully about exactly which technologies we need to use. Is the primary leak path coming through the stem seals? Is it coming from flange bolting? Do we have through seat leakage, which is not escaping to atmosphere but might be finding its way to a flare? Are the flange facings damaged? Have the body gaskets to trunnion bolting been damaged in some way the last time someone took it out? Is the RTJ ring damaged? You know, has the raised face become corroded? And then we can look at plugs and vents and all the fittings and other accessories that are attached to the valves. The sealant injection points, have they become corroded? Do we have a little damaged check valve in that one-way sealant injection port? When you start to look at it, there are so many potential leak paths that you couldn't possibly just use one tool to find everything. So I keep coming back to this jigsaw puzzle, and it's a join the dot exercise. Make sure we're using everything as much as possible. Now, one of the great things about working with a valve specialist company is the fix-it element of what I've been describing as our key 4 steps. Non-intrusive in situ repairs where we're using clamping devices, or we're doing that in situ repair that minimises your downtime, bearing in mind that's where most of your costs are going to come from when you do have a problem. Minimising that downtime is of massive importance. So anything we can do to give you a temporary repair to get you through to your next planned shutdown is going to have a massive impact in your accounts at the end of the financial year in the final analysis. Of course, we do also want to support you during the planned outage operations. And so there's a whole other rake of things that we can do, not just about replacing valves or accessories in and around valves, but looking at how existing valves can be repaired. So what is the break-off point? What is the balance, the break-even between putting a new valve in there that had a massive carbon footprint to produce versus doing a repair to some of the components which does have a marginal cost, but is much lower in terms of its carbon footprint. So again, we have to think about this wide open approach and have all of the solutions at the table ready to be deployed at the appropriate time scale so that we get to that zero emissions model. Looking at this in a real case study, this is a survey we started off with on an olefins processing plant. We took that 4-step process. We started off with a survey, 540 tonnes per annum of emissions were detected. We analysed that data and said, what can we do in the first instance to start reducing that footprint, that carbon footprint? That allowed us to do our non-intrusive maintenance activities that I described. And then because we put all our resources on the plant and stuck around until such time as we could do a full-blown supporting a turnaround activity, we looked at that intrusive maintenance model. So here's what we did. We repaired 170 online leaks. We had 8 isolation valves, which were injected with isolation barrier solutions, because again, those injected fluids have a massive benefit for you. 700 valve overhauls, 1,086 flange joints reassembled with new gaskets, flange faces remachined 221, and 142 new valves supplied. What was the outcome? Well, after our non-intrusive maintenance, we achieved 60% reduction in those emissions. And by the time we'd finished on the planned outage, we didn't quite reach 100% of emissions elimination, but we got very, very close. It was about 96%, if truth be told. The most important thing is, while we did the mitigation exercise, we saved the customer $700,000 per day in downtime. So even that step 3, where we made that 60% improvement, that's just in reductions. We also saved them $700,000 per day. So big numbers, they add up really fast. Key elements of the most complete emissions elimination programs. It's ideal if you've got
David,
a single... Yes?
we've got 5 minutes left till the next presentation. So if you'd like to begin your wrap up, that would be great. Thank you.
Perfect. Thank you. So ideally, we'll have a single source provider that joins all that data back together, because what you don't want to do is have multiple vendors with fragmented data sets. It's not going to give you the outcome that you require. You also want to be working with a subcontractor that does that find it, fix it, and continuously improved closed loop activity. We need to drive all our investigation work by criticalities. What's the probability of failure? What's the consequence of failure? That risk management piece driven by risk-based inspection. Taking the top-down approach requires quantification. So if your tooling is not giving you the cue, then you've got a problem. Bespoke engineering solutions will get you to the end point much faster than you otherwise would get there. So rely on an experienced contractor is the key message. And get on with doing those permanent and temporary maintenance repairs that move the needle from where it's currently at. Even if you can go and take that first 60% step, it's a massive improvement on where you're at. We've got lots of these studies that we can share with you. This is a study that I published on LinkedIn about how you reduce your total emissions through condition monitoring activities. So risk-based inspections and using the right tool at the right time will deliver these in the shortest possible timescale. I've said it many times, but I can't stress it enough. Use the right tools. Fastest route to net zero. I've already given away the game here. We know what you need. You need to be able to find the problem, quantify the problem, and then predict where that problem's going. So our focus is to find the leaks for you, give you the quantification, and do the trending. So LDAR is dead is something I said about 3 years ago, and people laughed. LDAR is dead because LDQAR is the future. We need that quantification piece to drive maximum change in minimum timescales. So if you're not doing quantification, it's going to take you longer to get there. So let's stop talking about LDAR. Let's get the whole community talking about LDQAR, and let's deliver those benefits as soon as we can. If anyone's interested in any case studies, what we've done for customers in terms of either repair methodologies or specific examples where we've been able to reduce emissions or save money or improve safety performance, again, we can share all these with you. I'm going to give you some contact details at the end here that you can get in touch with me either through LinkedIn or on our websites or through our EEP email address. There is a flyer. Again, I'm happy to email that out to anyone, but let's get on with doing the correct surveys with the correct tools so that we can do prioritized repair activities and continuously improve our processes over time. Once we do that, we will have no problem whatsoever in reaching net zero well in advance of 2050. So with that, I will thank you for your time. There is the email address that you can communicate directly with us, or as I say, you can find me, David Anderson, on LinkedIn, and I'll be happy to answer any questions on those channels, or indeed, if there's anyone in the room that has a question for me today, I will try my best to give you an answer. Hopefully I've met my time scale there. And thanks for your attention. Hope you enjoy the rest of the conference.